Let us start a new chapter today, Arithmetic Progressions. Arithmetic Progressions. Before starting arithmetic progressions, let us understand these terms: sequences, series, progressions, right? So that we can use them correctly. Now, sequences are a set of numbers written or arranged according to a definite rule, right? A set of number arranged according to a definite rule. Now, that rule may be mathematical or simply a logical rule, right? It may be logical or it may be mathematical rule, right? Let me give you some examples of sequences. For example, if I write this sequence 2, 4, 6, 8, 10, and so on. Now, this is a sequence having even numbers. Even numbers. So if I ask you what will be the nth term in this, you can say that 2n will be the nth term. 2n is the nth term. What do I mean by nth term? As 2 is the first term, right? 4 is second term. 6 is the third term. So what will be the nth term? It will be equal to 2n, right? Now, if I write another sequence like this 1, 3, 5, 7, 9, you can observe that I have written a sequence of odd numbers. A sequence of odd numbers. Now, these two sequences follow a definite rule and a logical rule that I am writing even numbers here. And this is also following a mathematical rule by which we can calculate the nth term. Nth term of this particular sequence is 2n minus 1. Right? If I replace n with 1, if I replace n with 1, I'll get my first term, which is 1. If I replace n with 2, I'll get my second term, which is 3. Similarly, in case of 2n, if I replace n with 1, I'll get 2. N with 2, I'll get 4. Right? This is the meaning of nth term. Now, let me write another sequence. 2, 3, 5, 7, 11, and I am talking now. This is a sequence of prime numbers, right? I have written prime numbers here. Now, this is a sequence, but it doesn't follow a mathematical rule for its nth term. I cannot calculate its nth term using a formula. There is no formula to calculate the nth term of these prime numbers, right? How do I calculate the next prime number? I just see the previous number and then I take a number and then check whether it's prime or not, applying a certain set of algorithm, right? But I do not have a definite formula for it. So all these three examples that I've taken here are sequences. Now, a sequence may be a progression, or not a progression, right? Now, out of these three examples that I've taken, these two sequences are progressions. But this third sequence that I took here, the sequence of prime numbers, is not a progression. What is the difference here? That I can write a formula for its nth term. Formula for its nth term. But in case of these kind of sequences, I cannot write a formula for its nth term. So the progressions are special kind of sequences of which we have a formula for nth term. Series is nothing but a sequence written with plus signs in between. For example, if I write it like this, now this is a series, right? I've got a sequence and I write it with plus signs in between, then it becomes a series. All right, so I hope you understand the difference between sequence, progressions and series. Now let us talk about arithmetic progressions. Arithmetic progressions. Now let us say I've got a sequence A1, A2, A3, A4 and so on till AN. Now these are set of numbers written here. If if the difference between any term and its previous term is constant, then such a sequence is known as arithmetic progression. Now what do I mean here is, if I take the difference of A3 and A2, now A3 minus A2 and difference of A4 and A3, A4 and A3, right? This term minus the previous term, this term minus the previous term. Now these differences are equal and equal to some constant, right? Then these kind of progressions are known as arithmetic progressions, right? So these differences are equal, and this D has got a special name which is common difference. Common difference. So if an is the nth term, then I can say that D, which is common difference, is equal to an minus 1, right, in general form. And what I mean by it, that any term, let us say 21st term minus its previous term is equal to any term, let me take some other term, A13 minus A12 will also be equal to D, that is the common difference. This is the basic definition of arithmetic progression. Now let me write a general arithmetic progression for you. Let me take A1 as my first term and D as common difference. Then what will be the next term? It will be A1 plus D. Next term A1 plus 2D. I'll keep adding D in the previous term, right? So to obtain the next term. So now to obtain the third term, I'll add D in this. Next term will be obtained by adding D in this. A1 plus 3D. A1 plus 4D. Now which term is this? This is fifth term. This is fourth term. This is third term. Right? You notice a pattern? This is second term. In second term, I had 1D. In third term, I had 2Ds. That means 2 into D. In third term, 2D. Fourth term, 3D. Fifth term, 4D. What can you tell me about nth term? It will have n minus 1D. Right? It will have n minus 1D. So this is my nth term, which is also known as general term. And in some of the books you may see that it is denoted by T, then this subscript n, or simply an, right? So this is nth term or general term, right? So if I want you to write 20th term, you will say a plus 19d. This will be 20th term. 15th term, a plus 14d, right? 27th term, a plus 26d, right, where a is my first term, or if you have taken a1 here, then you have to write a1. All right, otherwise if a is your first term and d is the common difference and you need to write 43rd term, let us say, you will say a plus 42d. Okay, let me clear this board, then we will proceed. So what have we learned so far? That if first term of an AP is A and common difference, let me write it like this, C comma D, common difference is D, then I can write this arithmetic progression like this: A plus D, A plus 2D, A plus 3D, right? In the first term, I had 0D, 0 into D, right? In the second term, I had 1 into D, right? 1 into D. In third term, I had 2D. So, what can you say about, let us say, rth term? It will have R minus 1 into D, alright? And what can you say about nth term? What can you say about nth term? It will be A plus n minus 1 into D. Let us say we have got this AP. AP is the short form for arithmetic progression. Now we have got this AP with n terms, right? So if I ask you what will be the rth term from the beginning, what will be the rth term from the beginning? You will say A plus R minus 1 into D. Okay, now you can read this AP like this. When you go from first term to second term, you need to add D. Second to third, you need to add D. Third to fourth, you have added another D, right? This is how you will go from left to right. But if I have to come back, for example, let us say from this term to this term, I'll have to subtract D from this, right? So if I take this term as my first term, okay, what I am trying to show you here is that if I start observing it from the end, right, and this is an n terms arithmetic progression, so this is my last term here. What I am trying to ask you is, if I ask you rth term from the end, how will you find the rth term from the end? Now this is the last term, and when I have to come back, right, I need to subtract D, all right, then I'll get the next term by subtracting another D, all right. So what can I say? If I think like this, if this is my first term and minus D is my common difference, then what can I say about rth term? Rth term from the end will be the first term, which in this case is A plus n minus 1 into D, plus R minus 1 into common difference. Common difference this time is negative D, right? So this is how you can obtain rth term from the end, which is, you can calculate it further, A plus n into D minus D plus, this is minus RD, this is minus RD, then plus D, right? This D can be cancelled and you will see that it is equal to A plus n minus R into D. So this is the rth term from the end of an AP having first term as A, common difference as D, and number of terms as n, right? So this is rth term from the end. Another observation that I want you to make here is that if you add A and A plus n minus 1 into D, what will you get? If you add this and this, that is the first term and last term, you will get 2A plus n minus 1 into D. Now think about the second last term here. You have to go to second last term by subtracting a D here. So what will be the second last term? It will be A plus n minus 2D, right? This will be my second last term. Now if I add my second last and second term, what will I get? Second term is A plus D, and I am adding this second last term, A plus n minus 2 into D. Now this will give me 2A plus, this is n into D minus 2D, and this is plus D. So it will be n minus 1D, which is nothing but same as the sum of first and last term. So you observe, excuse me. So you see a pattern here. When I added first term and last term, when I added second term and second last term, I got the same sum here, which is 2a plus n minus 1 into d. Can we generalize it? If I add rth term from the beginning and rth term from the end, will I get the same result? Let me check. This is rth term from the beginning, a plus r minus 1 into d, a plus r minus 1 into d, and this is rth term from the end, a plus n minus r into d. What will be the sum? A plus a will be 2a plus r minus 1 into d can be written as r into d minus d, and n minus r into d can be written as n into d minus r into d. So this rd and this rd gets cancelled, and 2a plus nd minus d, I can take d common and write it like this, n minus 1 into d. So yes, rth, sum of rth term from the beginning and rth term from the end is same, which is 2a plus n minus 1 into d. So I can say the sum of terms equidistant from the beginning and end is same, right? And we have seen that it is equal to 2a plus n minus 1 into d. So in this form, if I have written the AP a1, a2, a3, an minus 1, an, right, then I can say a1 plus an, that is first term plus last term, will be equal to a2 plus an minus 1, that is second term plus second last term. And if I write this third last term, an minus 2, then I can say a3 plus an minus 2 is also equal. You see the sum of these subscripts, this is 1, this is n. What is their sum? This is n plus 1. Sum of these subscripts 2 and n minus 1 is again n plus 1. Sum of these 3 and n minus 2 is again n plus 1. Right? So you should observe these patterns and keep these in your mind. These will help in solving the questions really fast. Okay? Next thing that I want you to observe is, let me clear the board first. When I write A1, A2, A3, A4, an minus 1, an, when I write the common difference, which is any term of this AP minus its previous term, right? This difference, which is D, is independent of n, independent of n. Why I am telling you this is that if you have to show that a particular progression is an arithmetic progression, you can show that the difference of any of its term and its previous term is constant, right? If it is independent of n, means that it is constant, right? This is one of the observations that I want you to keep in mind. Second thing, we talked about general term, that is an, right? It is equal to a plus n minus 1 into d, where a is the first term, d is common difference, and n is the number of terms. Now if you observe this expression, let me open this bracket first, a plus n into d minus d, or you can write like this, a minus d plus n into d, right? This a minus d here is independent of n. Okay, so let me write it like this, n into d plus a minus d. This term is independent of n, and this term has got a linear n, right? And what is the coefficient of n? What is the coefficient of n? It is common difference. It is common difference. So can I say about the general term of an AP that it is a linear expression in n, nth term of an AP is a linear expression in n with coefficient of n as its common difference, right? So when I observe this expression here, I can say that nth term of an AP is a linear expression in n. This is a linear expression here. This is a linear expression in n with coefficient of n as its common difference, right? This much you should be able to identify here. For example, I wrote 2, 4, 6, 8, 10, right? This was a sequence of even numbers. As you can observe, its general term will be 2n. Its general term will be 2n, right? And when I wrote these odd numbers, its general term is 2n minus 1, right? What do we mean by general term? That we will keep replacing values of n and we will keep obtaining the terms. If I replace n with 1, I'll get my first term. 2 into 1, that is 2, right? And in this case also, if I replace n with 1, I'll get my first term, that is 2 minus 1 equals 1. You observe the coefficient of n. Coefficient of n is 2, and what is the common difference? 6 minus 4, 2. 8 minus 6, 2. In this case, coefficient of n is again 2. What is the common difference? It is 2, right? So this is another observation that I want you to keep in your mind, and I will make use of these facts that I am telling you while solving the questions. Okay, let us discuss more such observations in the next lecture.